Hello, this video is going to be on sections 5.3 through 5.5, so 3 different sections in one video, and they're all about different equations of lines. And the learning target is to write and graph linear equations using slope-intercept, point-slope, and standard form. So there's 3 different ones we're going to be talking about today. One of them you should be very, very familiar with, and the other 2 may be a bit new that we'll introduce in this video. But 2 definitions before we get started. A linear equation is an equation that models a linear function, so anything that's a line, that's going to be able to have a linear equation where we can write it so that it models the behaviors of that function. Then there's a y-intercept, and that's the y-coordinate of a point that goes through the y-intercept or the y-axis. So if we have this equation right here, the y-axis is the vertical line, so the point that goes through that vertical line is considered the y-intercept. Every x value on a y-intercept is going to be 0, so the only thing we need for the y-intercept is the y-coordinate. The x's are always going to be 0. So the form that you're most familiar with is the slope-intercept form, which is y equals mx plus b, and the only thing you need for a slope-intercept form to write an equation is the y-intercept point, or any point that is 0 and the y-intercept, and then you also need the slope, which was in the last video I talked about rate of change and slope, and that's what is represented as m here. You don't need any other points on the graph. However, there may be some instances where you're only given another point that's not the y-intercept, and you have to calculate where that y-intercept would be. And that's what some of the examples in class are going to be like. But this is what you should be most familiar with, so I'm not going to spend too much time on it in the video. The next 2 are point-slope form and standard form. Now, point-slope is probably the most useful, or at least in my opinion the easiest one, because you need to use the least math in order to write an equation for it. All you need is a slope, again just like the last one, and an x-coordinate and a y-coordinate. It doesn't have to be the y-intercept. It could be any point along the line. That's why it's called point-slope. So the equation looks a little bit similar to the slope-intercept form, where you have an m and an x and a y. So this y and this x are present in that form of equation every single time. You're not plugging that in. The only thing you are plugging in is the slope into here and your x and y coordinates into here. Now, it's very important that in point-slope form you recognize that this operation here is going to be minus. So if you have a point that you're plugging in that is, let's say 2, -3 is your point, the x-coordinate is going to be 2, so when you plug it in here, it's going to be x minus 2. And then when you plug in your y-coordinate -3, it becomes y minus a -3, or it could also be a y plus 3. So the operation that you plug into the equation is the opposite sign that you see in front of your point. This is a +2, that's a -2. This is a -3, that's a +3. So that's what's a little bit different between this and slope-intercept. But if you're given a point and a slope, you can plug this in, and that equation is good to go. You don't have to do any math to solve for anything. It's just like that. Now, sometimes you'll have 2 points where you have to calculate the slope, and then you just pick a point based on that. But this is, in my opinion, the most useful and the easiest method of writing an equation. Now, having said that, going into standard form is what I think is, in my opinion, the least useful, because there's not really anything you can pick apart by just looking at the equation. Now, standard form is written in ax plus by equals c, and that is where the numbers a, b, and c are real numbers. They're not irrational or taking the square root of a negative. They're just regular real numbers. And the only criteria is that a and b can't be 0. So they could be negative, but they just cannot be 0. Now, when you're looking at this graph, you're not able to instantly pick apart and point at something and say, oh, that's the slope, or that's the y-intercept, or that's a point. This is the one where you do have to use a little bit of math in order to calculate that. But this is very useful later on when we talk about equations of a circle. Is probably what you're going to recognize this as being the most translatable. But this is the one that does require math in order to get it, in order to plug it in. One thing I will say about slope-intercept is that this is known as the calculator form. Calculator. I can't spell today. So this is the form that you always want to get your equations plugged into if you want to plug it into the graphing calculators. You can't use any other form plugging that in exactly the way it is. If you do some math to get it into slope-intercept form, this is the way you can plug it into the calculator. These other two, plugging it in exactly this form is not going to get you anything out of the graphing calculator. And then, like I said, this, you can actually pick apart something and see this is the slope and the point. Standard form, you got to do a little bit of math to solve for it. But in class, we're going to be solving from one method to another, or having to write equations of lines using different methods. I just want you to be familiar with all of them so that if you need to be able to write it in any form on a test or an ACT, that you will be able to do that. But in most instances, I will be working with you on point slope and standard form the most, since you've seen slope intercept already before. All right, thank you.